Hi, previously we talked about a case where when we try to use energy to predict, it doesn't reflect what happened at the end. And so I mentioned that, you can actually use another system called momentum and it can help us to predict. So let's get into it. The best part about momentum is that even when there is sound or heat energy that involve in the motion or even the collision, we can still predict what happened because for momentum, a certain physical quantity, they will still be conserved after the collision. So that's why we can use it because it's being constant as a whole system over time. Like no matter what time it is, it's still a constant. Just like if you consider the total energy, it's always the same. But the thing is, because we cannot really calculate the sound energy or the thermal energy during the collision that easily, and so we couldn't use the energy approach. So that's why there's another approach called momentum here. So first of all, momentum is defined as P equals to mv. P is a symbol for momentum, and mass times velocity will be m times v. And again, this is by definition. Okay, it's being defined this way, not derived. Isaac Newton defined it. And this is something that he found out to be constant, and that's why this becomes something that is very important in physics. And so like I said earlier, we find out the total momentum is being the same before and after the collision, and that's why we also call this as conservation of momentum. Just like what we say conservation of energy is the same idea. And so here we could express mathematically that is total momentum before the collision equals to the total momentum after the collision. And usually when we talk about in say IGCSE or even in IB physics, we are talking about two objects that collide to each other, and that's why we have m1 and m2 and their own initial velocity on the left hand side. So you can see this is one momentum, this is one momentum, and you add them together, so that's why it's total momentum before, because these are the initial velocity on the left hand side. And on right hand side it's the same, m times v for object 1, object 2, and their final velocity. So this is an equation that you will get to use a lot in this chapter, and it's something that you may need to rely on whenever you see a momentum question. However, when you try to apply this principle, we still have to fulfill one assumption. If this assumption is not fulfilled, then this law or this equation would not work, or it would not be valid. And that assumption I can tell you now, but later on I hope you can understand why it is that way when we try to derive this equation. And by the way, yes, we can derive this equation by yourself right now already, but I'll address that later on. So the assumption is that no external force, so you may want to put it down, no external force is acting on the system. Okay, so I don't think we should explain it now, because later on you realize why this is important when we try to derive it. Let's try a question together. Is that Snoopy running at a certain speed jump on a skateboard of mass traveling in the opposite direction. So here you may find, it's a bit hard to understand the question. So what I recommend you to do so is to draw the diagram out, and that is very essential, especially for this topic. You may not know what Snoopy is a dog, simply. Alright, so this is, I think, the best I can draw. Okay, how do you draw the body? I don't know. Okay, never mind. Okay, here is the Snoopy, here is the skateboard, and the most important thing is you want to label the quantity you find. So m1 is 10 kg, and then going in this initial velocity, so u1 equals to 4.5 meter per second. Here we've got a skateboard m2, 4 kg, and then u2 is going to be 7 meter per second going in this direction. However, you may find out, hey, it doesn't make sense, because if you remember when we talk about velocity, it is a vector, and so we have to choose a certain direction to be positive. So let's say here, it's really up to you really, but then let's say we choose the right hand side to be positive. Remember to label it somewhere in your question so that you would know. Alright, it's not about the marker would know, it's most importantly you know about it and you can do it properly. And so in this case, because of this definition, then u2, that means the skateboard velocity will become negative because it's going to the left, right? It's at opposite direction. And so now we can apply the conservation of momentum. So the equation, once again, you need to memorize it. That is mu plus mu. I'll put the numbers later on. mv plus mv. And I recommend doing that because you won't be mixing it up. Here will be 1, here will be 2, here will be 1 again, and 2. And so what you have to do next is simply substitute what you have. So m1 is 10, u1 is 4.5, m2 is 4, u2 is -7, remember? And then on the right hand side, you may find out, hey, we don't know about v1 and v2, right? Because the question didn't say about it. This is exactly what the question is asking actually. And remember, in this case, sometimes of course this is not, but in this case, you can imagine Snoopy is going to jump onto the skateboard, and so they will be moving together. Okay, and that is quite important because in this case, then v1 would equal to v2. Okay, it has to be the same. I mean, if you are on a skateboard and there's no slipping, right? Like that, you don't have a relative motion, and so you will be moving with the skateboard for sure. And so in this case, you can rewrite the right hand side as in m1 plus m2 because they will have the same v anyway. So you can kind of extract the v out, and I'll call it the big V, and m1 plus m2, and so that should be 10 plus 4. Okay, so this is leaving you only one unknown, and you should be able to resolve it. So eventually you should find a number that is 1.2142 something, and then I should run it to, I guess, 3. I think 3 is already quite a lot. I mean, I should run it to 2 probably, but then okay, I think 2 or 3 are both fine, so let's do it this way. Okay, so notice that this is positive, right? I mean, if you look at your calculator, you should find a positive value if you have the same direction definition. Right hand side is positive as me. And so if this is what you find, that means this is a direction that they will both move to the right. So if you want to, you can say right direction. Alright, let me give you one more example, and so you can try it out and see if you understand what we learned. So let's say we got 2 blocks. Just make it simple this time. The surface here is going to be frictionless. Okay, so that fulfills what we mentioned about the assumption earlier, that is there's no external force in this system. And so in this case, let's say m1 is moving at a certain speed, that is let's say 5 meters per second, and also m2 is moving also to the right but slower, let's say 1 meter per second. So well, obviously m1 is eventually going to collide on m2 because it's moving faster, although they won't collide at the same spot when they start. So maybe somewhere around here, I don't know. I mean, they will eventually collide. That's the most important. As for m1, let's say it is 3 kg, m2 let's say is 5 kg. Okay, I just make it up. And so let's just say what I know after they collide, m1 will bounce back. Okay, maybe I use another color. It will bounce back with a speed that is going to the velocity that's going to the left, let's say 2 meters per second. And I want to ask you, so what happened to m2? Let's say it is going in this direction, and we define it as V2. So what would V2 be? Pause the video and try it yourself.
A few moments later.
Alright, let me try to do it. First of all, you have to define the direction of the direction. So let's say again, we do right hand side to be positive. So you have to clearly write it somewhere at the very beginning to remind yourself that. And the second thing that you should be aware of is that I try to trick you because V1, as I said, the magnitude is 2 meters per second, but then since this is a vector, when we try to consider the velocity and also momentum itself is actually a vector. And so here we would have to keep it as negative because we define right hand side as positive. And so after these are all done, then I think you can start to recall the equation. So again, it should be m1 u1 m2 u2 equals to mv plus mv 1 1 2 2. Okay, and then basically you should have everything except v2, and that should resolve the whole thing. You just have to be more careful about the direction simply. So let me just do it quickly. 3 times 5, 5 times 1, they are both going to the right, so yeah, that's fine. And then 3 times negative 2, Vm2 is 5, and then V2. Okay, and so eventually you should be able to find using calculator, and the answer should be 5.2 meter per second. So yes, again, this is positive, and so M2, that block, should move to the right hand side. That is the end of this video, and in the next video we'll try to derive the formula that is the conservation of momentum, the one that you have been using twice in this video. I'll see you again in the next video. Bye.